Straight lines in 2D starts with the concept of the topic you have already completed in class 10. If we start from the beginning, this is straight line in 2D. Straight line may be there in 3D. In other higher dimension, we will not be discussing. 3D application and the concept you will find in class 12. 2D means a point has coordinate of this form, which is known as ordered pair. Ordered pair X is known as abscissa and Y is known as ordinate. Okay? X is known as abscissa and Y is known as ordinate. So, origin is O. If there is a point Pxy, then O to M, the distance will be X, and P to M, this will be Y. This is the coordinate of a point in two-dimensional coordinate system. It may be first coordinate where x, y both positive, maybe here. Here the point has a coordinate of this form minus xy. It may be here. It may be here also. Fourth quadrant, y is negative, x positive, so coordinate of point may be of this form. In class 10 syllabus, you have done distance formula and section formula. Only these two topics were there. If 2 points A and B are there, x1, y1 and x2, y2, then d equal to distance between AB, which is given by x2 minus x1 whole square, y2 minus y1 whole square. This you did before. No need to derive it now. And then, if there is a point P which divides AB in the ratio M is to N, then we get coordinate of the point P as mx2 plus nx1 by m plus n, and y coordinate my2 ny1 by m plus n. This is called section formula. Any point, if we know the distance of the point from one of the extremity or the ratio between two distances known, then we can write the coordinate of the point. Coordinate of origin is 0, 0. Any point on x-axis has the coordinate of the form A0, a point on y-axis has coordinate of the form 0, b. Okay. And then using this concept, we can easily derive area of triangle formula. Area of a triangle in 2D. How to find the area? So, in 2D, everything determined by coordinate of the point. So, if there is a triangle in 2D, that triangle be A, B, C, then this point is x1, y1, this is x2, y2, this one is x3, y3, okay? We have to find the area of triangle ABC. This we are going to prove in this form, which is known as determinant. If you remember, it's okay. Otherwise, you write this one as half x1 into y2 minus y3, value of this thing. When you take x2, it will be y1 minus y3. Okay? These are 3 points, no? x1, y1, x2, y2, x. I am going to prove it. But finally, what you will get, that I am writing here first. 3 points are this: x1, y2 minus y3, x2 into y3 minus y1, as you are not familiar with the concept of determinant, I will tell you to remember this formula, half mod of this thing. Okay? x1, y2 minus y3, x2, y3 minus y1, x3, y1 minus y2. But how to prove this? This I am going to tell you. From here, you draw a perpendicular. AL, draw a perpendicular here. CM and here also. This is N. Okay? These are all perpendiculars. So in diagram, area of ABC is what? That is area of trapezium ALNB minus area of trapezium. This is trapezium, no? Because these are parallel. And this one is also trapezium because BN is parallel to CM. Area of trapezium BNMC. Clear? Area of this trapezium ALNB minus plus area of trapezium BNMC minus another trapezium is there, area of trapezium ALMC. Am I clear? We have to find, no, this is not rectangle. Who told you that? y1 equal to y3. This part is y1. This is y3. They are not on the same horizontal line. It is not parallel to x-axis. There may be a special case, but here it is not. And this one is y2. Bn is y2. Isn't it? Which part is x1? This is x1. This part x2. And O2M, that part is x3. Agree or not? This thing going to be, because this has coordinate x3, y3. So origin to this point distance will be x3, and M to C, this distance will be y3. This one is x2 and this is y2. This one is x1 and this is y1. Clear? What is area of trapezium? You know, half into sum of parallel sides for A, L, and B. This is y1 plus y2 into distance between them is ln. Area of BNMC is what? Half into y2 plus y3 into distance between them, that is x3 minus x2 minus area of ALMC. Again, half into sum of two parallel sides into x3 minus x1. Clear? So this way we can write the area of triangle ABC. We want positive sign always, that so we change accordingly. So now half you take common and multiply all these to simplify. Clear? So how to? This calculation I will be taking in this manner. After taking half common, we just write x2, x1, y1 plus y2, just open the bracket. Alright. Now this will be half. Take x1 together. What is x1? That you can see easily. We will be taking x1 together. That is this x1 and this x1. x1, y1 plus y3 plus x2 minus y2 minus y3 plus x3 into minus y1 minus y3. Okay? Now just simplify it. Half, these two are getting cancelled. x1, I am taking minus common to get the pattern. Already I told you, that's why taking minus common. Doesn't matter. minus x2 common, minus x3 common, okay. So all terms contain minus sign, and area you never write negative, at least here. So all are considered, area considered positive. So you take mod of this thing, mod of this thing, mod of this thing, mod of this, take minus common, half x1 I have taken minus common, minus out. Okay. So if I follow this sequence, I am writing here for your better memorization of the formula. A is x1 y1, B x2 y2, C x3 y3. Okay. Now, how to remember the formula quickly? When you take this x1, then you do y2 minus y3. Next, x, turn of x. When you take x, apart from this y, this minus this, see y3 minus y1. When you take this x, the next y you come back here, it is y1 minus y2. Clear? I am just showing you one example. Example 1. Find the area of triangle ABC if A is given 2 minus 1, B is 3, 2 and C is minus 4, 6. I apply this thing direct. How to? We are writing area equal to half mod. This is our x1 y1, 2 into y2 minus y3, 2 minus 6 plus 3 into 6 plus 1 minus 4 minus 1 minus 2. So there will be half into mod of minus 8, 21, 12. It's coming 12.5 square units. Okay? It's coming 12.5 square units. So when you are going to find the area of the quadrilateral ABCD, whose 4 vertices given this manner, five minus 5, you just find area of ABC, area of ADC and add them up. So, area of ABCD is area of ABC, take mod of this, plus Okay? Because if you get area negative and add with this, then actual area will be less than which it was supposed to be. So make modulus in the beginning. Find area of ABC. Half mod of, you need not take mod over the area. If you find by using mod, then that is enough, isn't it? We make it mod in the formula part. So this will be minus 4, 7 plus 5, 0, 5 minus 7 mod. Okay? So there will be half mod of so 58 by 2, 29 square units. Then we'll find area of ADC. How to? That is half into ADC mod minus 4 minus 2 plus 5 ADC, keep this order only, plus, oh again minus 4 plus 5 into half into five into 7. So there will be half (75 minus 12), 63 by 2. That is square unit. So required area will be (60.5) square units. Under what condition 3 points condition for collinearity of 3 points. If 3 points lie on the same line, no triangle can be formed. (3x3 y3). So these are 3 points, they are collinear if A, B, C are collinear, then area of ABC should be 0. That is half into wait a minute, x2 y3 minus y1 x3 y1 minus y2 0. Therefore plus x2 So this is the condition for collinearity of 3 points. Just apply this concept in solving this problem. Check whether A 1 2 3 minus 1 and C 2 minus 3 are collinear or not. We have to check. These 3 points are collinear or not. How to check? So you just find the area of ABC. If it is equal to 0, then they must be collinear. Half 1 plus 3 plus 2, 2 plus 1. Just simplify it. This is going to be half 2 plus minus 5 plus 2 into 3. Check once more. 1 into minus 1 plus 3. 3 into minus 3 minus 2. 2 into 2 plus 1. 2 into 3 6. 3 into minus 5. And that is 2. So it is going to be half into mod of minus 7, not equal to 0. So what will be the conclusion? Given points are not collinear. Okay? Understood? So area of triangle, area of parallelogram, quadrilateral, all these can be determined by the same formula. I am not going to derive in a new formula for area of any quadrilateral. That also can be written, but I will prefer to remember this one to find the area of quadrilateral. Okay? Too many formula will make maths more complicated. So I will not encourage. Next one is going to be that slope of a line. Slope of a line. Okay? What is that? There is a line which makes some angle theta with x-axis. If a line makes an angle theta with x-axis, then its slope is given by m equal to tan theta. This is the definition. Okay? Tangent of the angle made by it with positive y-axis. With we'll remember positive x-axis, not y-axis. Okay? Now, we'll write the value of slope of line in some cases. Like, say, line is there. This is the line. Okay, I'll do it in different line. This is the line. It makes 30 degree with y-axis. Can you state the slope? You try to write. Before that, before doing it, I'll be writing a few more diagram. I'll draw a few more diagram to find the slopes. This is the line which makes an angle 135 degree with x-axis. You have to write the slope. There is a line of this form. This is 15 degree. What is the slope of this line? These three cases. First case, the line. We need to know the angle made by it with positive x-axis. Isn't it? Positive direction of x-axis. By geometry, this has to be 30 degree. So this is going to be 60 degree and this angle is what? 120 degree. So slope in this case will be tan 120 degree. Isn't it? Slope of the line is tan 120 degree. What about this case? It's quite obvious. It makes 135 degree. So M going to be tan 135 degree. This is minus 1. Okay. Slope of the line is minus 1. Because with positive direction it makes 135 degree. What is the slope of this line? It will be M equal to tan 15 degree. We remember its value. I think you all remember it is root 2 minus 1. Or root 3 minus 1. Sorry, root 3 minus 1. Why? How? Compound angle formula. Tan of this is nothing but by one minus 1 by root 3. Remember it. Root 3 minus 1 by root 3 plus 1, rationalize, multiply by root 3 minus 1. I actually have written the wrong answer here. Multiply by root 3 minus 1, both inner and rear. That's what I'm doing. And this will be root 3 plus 1, root 3 minus 1, 3 minus 1. So tan 15 degree going to be this divided by 2. 3 plus 1 so in this case slope is going to be 2 minus root 3. Okay. Now, what will be the slope of line joining two given points? Let us do it. To find the slope of a line joining two points A x1 y1 and B x2 y2. To find the slope of a line joining these 2 points A x1 y1 and B x2 y2. How to? Very easy. We'll remember slope of line as tangent of the angle made by it with positive x-axis. X, y, there is a line passing through these 2 points, x1, y1, and B, your problem is to find the slope of this line, tan theta. So to find the value of tan theta in this case, you just draw perpendiculars. AL and BM are 2 perpendiculars. Join a perpendicular from here to here also. AL to BM, that is AR. Okay? Now in this diagram, if this one is theta known, this one has to be theta. The same line, and this perpendicular is parallel to x-axis. So this one theta means this has to be theta. Now in this diagram, in triangle ARB, this part is x1, x2, y1, y1, and this part is y2 minus y1. So this part going to be what? x2 minus x1. So in triangle ARB, tan theta going to be BR by AR. y2 minus y1 by x2 minus x1. We can easily get the value of tan theta by using this formula, and hence the value of theta. Okay? So let us write a sum here. Find the inclination of a line with x-axis passing through the point two, 3 and 4, 6. So we'll find the value of tan theta from there, and then the value of theta. How to? This is your x1, y1, and this is x2, y2. So tan theta is y2 minus y1 by, unfortunately this doesn't give us any particular angle. Only you can say that theta can be determined from here. In your calculator, theta will read this one. Shift tan and put 3 by 2 inside bracket. Then you will get theta. Understood? Calculator, there is shift button. Tan, shift, tan, bracket will arise, put 3 by 2 over there. The angle theta will come out. Or you simply state that theta can be found from there. Okay? So this way, slope of line passing through 2 points can be determined. Now, this concept will help you to get the angle between two lines. We are going to find angle between two lines. Angle between two given lines. Two lines are given, we have to find the angle between them. Two given line means their slopes will be given. Let the slope of two lines be M1 and M2. This is first line, this is your second line. Let the slopes of two lines be M1 and M2. This is M1 and this is M2. Okay? Now let this angle, the first line make, this line 1, it makes theta 1. Second line makes theta 2. Let L1 and L2 make angles theta 1 and theta 2 with x-axis. Okay. So what is the value of M1? For this line, M1 is what? Tan theta 1. For this line, M2 is what? For second line, L2, L2. This one L2, M2 is tan theta 2. Okay. So M1 is tan theta 1 and M2 is tan theta 2. Let theta be the angle between two lines. Then theta 2 equal to theta plus theta 1. Agree or not? One exterior angle will be sum of two interior opposite angles. So theta will be theta 2 minus theta 1. So tan theta will be what? Just take tan of two sides. Tan theta 2 minus by 1 plus okay. So tan theta going to be M2 minus M1 by 1 plus M1 M2. Theta can be determined from here. You can find theta the way I told you. I am writing the symbol once more here, although it will not be very convenient term for you, but you can practice this way. Theta will be tan inverse m2 minus m1 by 1 plus m1 m2. And one thing, you should make it very clear that this should be modulus, because between two lines, between two lines there are two angles, one interior, one exterior. So you always find this interior angle theta, not 180 minus theta. Okay? Answer you can give in terms of 180 minus theta also, but normally people do with the acute one. That's why we will make it sure that tan theta is always positive. If it is not positive, make it positive. Just write taking plus sign. Or from the beginning you write this one, mod of tan theta 2 minus tan theta 1 by 1 plus tan theta 1 theta 2. So theta going to be like this. Now two lines may be parallel lines. For parallel lines. For parallel lines, is there any angle between them? No. Because lines we are taking parallel. How can there be angle between them? They are parallel. So no theta is there. Here theta is 0 degree. So this line says slope m1, this one m2. Since theta equal to 0, therefore tan 0 equal to mod of tan 0 0. So mod of m2 minus m1 equal to tan 0 into mod of 1 plus m1 m2. Just do the cross multiplication. What have you got? Mod m2 minus m1 0. m1 equal to m2. So therefore, two lines are parallel if they have the same slope. Two lines are parallel if they have the same slope. Okay? Their slopes must be equal. Then they are parallel. Angle theta may be there, not equal to 0. Theta may be equal to 0. One more special case is there, that is when theta is 90 degree. What will be the condition for them? This is the formula. Tan theta equal to this. Now for perpendicular lines, we are going to derive the condition. For perpendicular lines, x, y. These are two lines, L1 and L2. Angle pi by 2. Okay? So theta pi by 2. This line has slope m1, this one has slope m2. Okay? So tan theta by formula is what? m1 minus m2 by 1 plus m1 m2. Okay? tan pi by 2 will be, one thing you can write this as, in some books you will find they are writing m1 difference m2. Means whichever larger you take it first. That divided by 1 plus m1 m2. Somehow you need to make this one positive. So there will be m1 minus m2 by 1 plus m1 m2. I am taking difference. Maybe m2 minus m1, maybe m1 minus m2. So 1 by 0 m1 minus m2 by condition for perpendicularity will be one plus m1 m2 equal to 0. That is m1 into m2 equal to minus 1. Okay? This is the condition for perpendicularity of two lines. Product of slopes will be minus 1. Therefore, if two lines are perpendicular, then the product of the slopes, product of their slopes must be minus 1. Should remember this. So let us solve one problem based on slope formula first. Example 1. Find the angle between two lines whose slopes are root 3 plus 1 by root 3 minus 1 and use formula only. No other method, just by drawing and finding. Just use formula. Formula you should learn, and sometimes drawing diagram also helpful. Okay, this is M1 you say, and this one M2. You have to find tan theta, and from there we can get theta. So here tan theta going to be what? Let theta be the angle. So tan theta is, which one larger? You can see M1 larger, you write simply difference or mod or this thing. By observation we found this one larger. 1 plus M1 into M2. Just put and simplify. Before putting also you can simplify. One plus M1 M2. LCM will be root 3 minus 1 whole square, and here it will be 1 plus 1. So this divided by, so 3 plus 1, 3 plus 1 getting cancelled. You know, 3 plus 1. So only thing is root 3. So tan theta is what? Root 3. So theta going to be 60 degree. Angle between them going to be equal to 60 degree. Actually, this one is tan 75. So this is 75 and this is 15. 75 minus 15 is 60. For MCQ, do that. Otherwise, you have to find it by this. Okay? Slope of a line double the other. If tan theta 1/3, what is tan theta? This actually I have taken, theta is the angle between, it denotes angle between two lines. Your problem is to find the value of two slopes, M1 and M2. So start this manner. Let slopes be M and 2M. Put tan theta you put 1/3 M by 1 plus 2M square. Clear? Hope you have understood. Now, when we are going to remove the mod, we should take a plus minus sign here. M by plus minus 1/3. So take plus sign. M by equal to 1/3 So we are getting two values of M here. Therefore, M is half and 1. Here one slope is double the other, isn't it? Now, will you get different answer if you take minus sign? So let us do that also. Taking minus sign. I mean M by therefore so it is 2M square plus 3M plus 1 0. Go by Milgram break factorization. 2M. So it's coming to me 2M plus 1. So what? M is coming minus half minus 1. 1 is double the other. So both are possible. It may be half 1, it may be this pair or this pair. Because then one slope is going to be double the other. The base of an equilateral triangle with side 2A lies along y-axis such that midpoint of the base is at the origin. There are two possibilities, you have to find both. Midpoint of the base at origin. Let this one is the base. LM is the base. Origin means 0, 0. Length of this part 2a, so this will be 0a. This will be 0 minus a. We have to find the vertex A of this equilateral triangle. Okay? Sorry. We have to find the area of, we have to find the vertex of vertex A of the equilateral triangle. This length is 2a, but who told you that vertex will be lying on the right side? May not be. It may lie on the left side also with the same possibility that it is going to be an equilateral triangle. It may be here also. A dash may be minus b 0. But it is confirmed that in both the cases it will be equilateral. Length of side will remain 2a only. So this is 2a, this is 2a. You need to find this length b. Then minus b automatically will come. They are of same length. But how to? Use figure. Use figure. This one is what? Pi by 3. This is A. O. So in triangle OAM, what do you observe? Tan pi by 3 OA by OM. OA is B by A. So this point has coordinate a root 3, 0. This one has to be minus a root 3, comma 0. Clear? Understood? A we need not find, just vertices. 3 vertices are there. This one a root 3, 0. This is 0a, 0 minus a. If you take triangle ALM A dash, then 0a, 0 minus a and minus a root 3, comma 0. Answer will be in terms of given quantity. Which one is given quantity here? 2a or a is given. That's why we can keep the answer in terms of